So good morning. So welcome to Narayan Green College online classes. So in the last video, we have discussed about the definition of dipole moment. Clear? So what is the dipole moment? And you know the definition of dipole moment is the product of magnitude of charge into distance between the two oppositely charged ions. Clear? So that we will call as a what it is? It is dipole moment. And dipole moment, and it is mainly used to measure the polarity in the polar molecule. Clear? That is the second point we have discussed. And units is debye. I already said what debye is equal to, and 10 power minus 18 ESU centimeter. Clear? And for diatomic molecules, that for dipole moment is equal to dipole moment of the polar bond, or simply we can say the dipole moment is directly proportional to difference in the electronegativity. Clear? For diatomic molecules, more the difference in electronegativity, greater will be the difference in electronegativity, greater will be the dipole moment. Clear? So simply we will consider the dipole moment of that polar bond only. But if you go for polyatomic molecules. For polyatomic molecules, you should not take here the dipole moment of individual bond. You have to consider the here net or resultant dipole moment of individual bonds. Clear? That also I have explained. Resultant dipole moment you have to take. Clear? Because in the polyatomic molecule there will be more than one bond, so that's why resultant dipole moment should be considered. Clear? I have taken examples also. And if I take simple example, another one simple example, CCl4, and if you take CCl4, here what it is now? Chlorine, and here there will be a chlorine, and here there will be a chlorine, and here there will be a chlorine. This is one example. Clear? You know carbonated chlorine, and you know this is more electronegative, so dipole moment direction is always from less electronegative atom to more electronegative. And here also. Clear? Here also. And this is dipole moment direction, and this is the dipole moment direction. So the resultant of these three dipole moments, see, this is in this direction, another is in this direction, another one is like this in this direction. So what will be the resultant? Resultant will be this one in this direction. Resultant will be clear. So this is the resultant. So and this one is exactly opposite. So that's why it will be cancelled. All the net dipole moment will be equal to 0. So here what we are considering for polyatomic molecule, net dipole moment should be considered. Clear? That I have already explained in the last class. Clear? So now we have discussed about applications. Clear? Applications of dipole moment. The first application here is in determining the polarity of the bond. The first one is in very important these applications are in determining the polarity of bond. Polarity of bond. So in determining the polarity of bond, and we have already discussed what is the formula for dipole moment. Dipole moment mu is equal to Q into D. Q means what? Charge, and D means what? Distance. Clear? The product of charge and distance will be considered as a dipole moment. You know that. As the charge increases, dipole moment increases. As the distance increases, dipole moment also increases, because dipole moment is directly proportional to charge and distance. But you know that if greater the charge, greater will be the polarity. Greater will be the what it is called? Polarity. So that's why greater the dipole moment, greater will be the polarity of the bond. That is the point. Clear? So what it is here? Greater the dipole moment. U means what is called dipole moment. Clear? And higher will be the polarity. Higher will be the polarity of bond. Higher will be the polarity of bond. Clear? Means which direction here? Directly proportional. Means mu is directly proportional to polarity of what? Polarity of this is. Clear? This is the answer. Clear? As the charge increases, definitely polarity. When polarity increases, automatically charge increases. If charge increases, dipole moment decreases. Means directly we can say dipole moment is directly proportional to what is the polarity of the bond. Clear? But for some cases, for non-polar molecules, if you take, clear? For non-polar molecules, polarity will be, means dipole moment will be 0. So what are those non-polar molecules? If I take H2, N2 and O2, etc. like, clear? So these are which molecules? These are non-polar molecules. Non-polar molecules. For non-polar molecules, dipole moment will be 0. Why dipole moment 0? Suppose if I take hydrogen and hydrogen, and both are same electronegative atom, and these bond pair electrons are lie between these two. This lone pair of electrons, not lone pair of electrons. This bond pair of electrons will not shift to any hydrogen to generate the poles. So here, charge here, poles will be 0. Charge will be 0. If charge is there, dipole moment will be what is 1? 0. So that's why for diatomic means for non-polar molecules, mu is equal to what it is here? 0. Why means because and for these molecules, polarity means poles will be charged will be 0. Clear? So that's why it says means if I write here mu is equal to 0, this is for which one? For non-polar molecules. For what it is here? Non-polar molecules. Clear? But another one, if any means for any molecule, sometimes what happen in the molecule there will be a polar bond will be present, but net dipole moment for those molecules are 0, and those molecules can also be considered as a non-polar molecules only. Clear? So best example I will say here BF3, boron trifluoride. If I take boron trifluoride, what I can write now here? This is fluorine, and here this is fluorine, and another one is what it is not fluorine. Clear? So here this bond is a polar bond. Why? Because fluorine is more electronegative than the boron. So fluorine gets with charge, negative charge, boron gets with charge, positive charge. Charge is there. But here for non-polar, this type of homodiatomic molecules, and charge will be 0. So that's why dipole moment is 0. But this type of molecules, already charges are there. But if you see the dipole moment direction, these three bonds are polar bonds only, and the dipole moment direction is always towards the highly electronegative atom, and here this is the dipole moment direction. But you see, take the resultant of these two. Clear? So it is the dipole moment direction for this bond is towards that, and this is this, and not like this it is. You see, this is the dipole moment direction for this, and this one is dipole moment direction is this. What will be the resultant? Resultant will be in this direction. So this is the for these two bonds, resultant dipole moment is in this direction, and that one and this dipole moment, BF dipole moment, both will be opposite direction and same magnitude. So what will happen now? Net dipole moment will be here 0. What my point? If you take any one, the resultant of any two will be cancelled by the third one. So that's why even though the bonds are polar, but net dipole moment will be 0. So those type of molecules will be also considered as a what it is here non-polar molecules. Clear? This is we can by using and by using dipole moment we can and easily determine the polarity of bond. If mu is not equal to 0, then the bond is a polar bond. Mu is not equal to 0. Finally, what we can write here? Finally, we can write here mu is not equal to 0, and those are polar molecules. Those are which molecules here? Polar molecules. If mu is equal to 0, those are non-polar molecules. Non-polar molecules. If polar molecules are there, and the bond will be polar bond. Polarity we can say. This is important. This is the what it is known here first application of dipole moment. And the second application in determining the ionic character. Clear now? In determining the second one in determining the ionic character, percentage of ionic character, percentage of ionic character in covalent bond. Clear now? Second application is here. So in determining the percentage of ionic character, how to calculate percentage of the ionic character in a given bond means percentage of ionic character is equal to mu observed divided by dipole moment, observed dipole moment divided by calculated dipole moment into 100. This is the formula. By using this formula, we can easily calculate the ion means percentage of the ionic character in a given molecule or in a given bond. Clear? So if we do one example, we can easily understand. So how to calculate this? Means in the question they will give observed dipole moment, and you have to calculate the dipole moment, calculated dipole moment. You have to calculate the dipole moment and multiply with 100, and you will get the answer for this question. Clear? So what is the question? I will write here. So calculate the write here question. Calculate percentage of ionic character, percentage of ionic character in HCl. Clear? In HCl. Given that observed dipole moment of HCl is 1.03 D. Clear? Distance of HCl is 1.275 angstrom. This is the question. Clear? So what we have given? They are asking calculate the percentage of ionic character. Observed dipole moment for HCl molecule they have given. Distance between the hydrogen and chlorine also given, and they are asking calculate the percentage of ionic character. Clear? So we will solve this problem here. So first what they have given, we have to write mu observed. How much they have given? 1.03 divided. Clear? Distance D they have given. Distance D how much what they have given? 1.275 angstrom. Clear? Now they are asking to calculate the percentage of ionic character. See now we have the formula. Percentage of ionic character is equal to mu observed by mu calculated. We know mu observed, but you have to calculate the what it is here. Mu you have to calculate. Yeah. So what is how to calculate mu? Because they have given HCl. HCl means how it will be. It is a polar bond. It is a polar bond because when this bond chlorine is more electronegative than the hydrogen, bond electron will shift towards the chlorine. So hydrogen is losing electron means it acquires which charge? Positive charge, and this is a negative charge. Clear? And if these bond electrons are moving towards like this, then what we are getting? Hydrogen is getting partial positive charge and negative charge. 1 unit charge is there. Clear? Now you know to calculate. We have to calculate. This is Cal means calculated. Observed means observed they have given. This is what is the formula here? Q into D. D we already know 1.275 angstrom. What you must know? Q. You know charge. What is the charge here? 1 unit charge. 1 unit charge means you already know what is the charge value here. 1 electron charge or positive charge, whatever it may be. That is 1.06 into 10 power minus 19 coulombs. Clear? R 4.8 into 10 power minus 10 ESU. This is the value of 1 unit charge. It is in coulombs and it is in ESU. You have studied already in the atomic structure. Clear? So means it is 1 unit charge, so that's why I will take this one ESU, because we know the relation between ESU and D. So that's why Q is equal to 4.8 into 10 power minus 10 ESU into distance of which they have given 1.275 angstrom. Clear? What I can write here, 4.8 into and 10 power minus 10 ESU into 1.275 into 10 power minus 8 centimeter, because you already know what it is. 1 angstrom is equal to 10 power minus 8 centimeter. Clear? So if you multiply 4.8 into 1.275, you will get 6.12. How much more here? 6.12 into 10 power minus 10, 10 power minus 8, 10 power minus 18. What are the units here? ESU and what it is now? Centimeter. Clear? You already know that here. You already know 1 divide is equal to 10 power minus 18 ESU centimeter. We have already discussed this. Previously I have given this value. 1 divide is equal to 10 power minus 18 ESU centimeter. 10 power 18 ESU centimeter means what I can write now? 6.12 into divide. Means 6.12 divides here. Clear? So this is what it is now. Mu calculated. Now ionic percentage of ionic character easily we can calculate. Ionic character is equal to, what is the formula? Formula is mu observed divided by mu calculated into 100. So what is the first one? They observed, how much they have given? Observed they have given 1.03 and here divided by 6.12 into 100. Roughly you will get 83 percentage. Clear? 83 percentage. This much of ionic character will be there and remaining percent will be covalent character. Clear? So this is how we can determine the percentage of ionic character in the covalent bond by using the dipole moment. This is the second application. So next one is third application in determining the symmetry or shape of a molecule. Clear? So simple here. If mu is not equal to 0, clear? Some compounds having 2 or more than 2 polar bonds, clear? And 2 or more polar bonds, and those compounds are not a symmetrical compounds if the dipole moment will be not equal to 0. If dipole moment is not equal to 0, then those molecules will be called as a unsymmetrical molecules. Unsymmetrical molecules. Unsymmetrical molecules. And if mu is equal to 0, and those type of molecules we will call as a symmetrical molecules. Symmetrical molecules. Clear? I will take example. Clear? So these are, means what it is. Mu is equal to 0, symmetrical molecule. Mu is equal to not 0, unsymmetrical molecule. Means we can say the shape of the molecule. The molecule is having symmetry, means symmetrical or not. Clear? Suppose I will say a previous example only I have taken here. I will take BF3 boron right now. Clear? You see central atom having all central atom is attached, all the similar atoms only, similar atoms, and dipole moment is 0. For this one you already know, dipole moment is equal to 0, then this molecule we will call as a symmetrical molecule. Means simply, for symmetrical molecules always dipole moment will be 0. So I have already mentioned why it is a dipole moment 0 here. This is dipole moment will be 0. Clear? This is symmetrical molecule. When the molecule will be symmetrical, if the surrounding atoms which are attached to the central atom are similar. Clear? That is. That time dipole moment, what resultant dipole moment is in this direction of these two bonds, and this dipole moment and this dipole moment are exactly opposite and same magnitude, because this is also due to the fluorine and this is also due to the fluorine. Opposite direction, same with same magnitude. So resultant dipole moment will be 0. This molecule will be called as a, which molecules are here? Symmetrical molecules. Symmetrical molecules means the molecules in which the central atom is attached to the same type of the atoms, and if the dipole moment is 0, and those molecules will be called called as a symmetrical molecules. Clear? Unsymmetrical molecules if you take. Suppose if I take here ammonia. So this is ammonia and here there will be a lone pair. Clear here? So for this one, you see here also same central atoms, same atoms are attached. But for this one, dipole moment is not equal to 0. And this, because you know, this is the dipole moment direction from less electronegative atom to more electronegative atom. This is the dipole moment direction. This is the dipole moment direction. You know, lone pair, that dipole moment direction is always upwards. So what will happen? That is, for these three, this is clear. What will be the resultant for these three? These three resultant will be like this. Clear? So resultant will be added here. Added to what it is. So dipole moment of lone pair. So that's why it will have some dipole moment. Means dipole moment for this molecule is not equal to 0, and those molecules we will call as a unsymmetrical molecules. Unsymmetrical molecules. Clear? So this is the concept. By using dipole moment, we can say that molecule is a symmetrical molecule or unsymmetrical molecule. Remember, always for symmetrical molecules, dipole moment will be 0. Clear, my dear? That is clear. Next one. Next one is, fourth one is effect of electronegativity and bond length on dipole moment. Bond length on dipole moment. Remember, this is very important question, and these all applications are very important because, and in the competitive definitely one question will come from this area. Clear? So what I mentioned here, effect of electronegativity and bond length on dipole moment. Clear? Suppose I will write here CH3F, and the same question you will study in the second year also. CH3Cl, CH3Br, CH3I. So they will ask, write the dipole moment order for these molecules. Clear? Means you already know dipole moment is equal to charge into distance. Clear? But for this molecule, you know, in this molecule you have to consider both the electronegativity and the dipole moment. Why? Greater the electronegativity, greater the polarity. Greater the polarity, greater will be the charge on the atoms. The charge is greater, automatically dipole moment also greater. But you don't consider here electronegativity. Why? Electronegativity difference you have to see only for the diatomic molecule. Diatomic molecules are there, and we can say there greater the difference in the electronegativity, greater will be the dipole moment. But in this case, in this type of case, this is not a diatomic molecule, so we should not consider that concept here. Clear? So what you have to do? In this one, first of all, I will write here CF bond here, and here CCl bond, CBr bond, and Ci bond. If you take here, what is the bond length R here? Bond length I am writing here, bond length R. Where the bond length, you know, all cases carbon, and here as the size increases, bond length also increases. Carbon case, a small one, fluorine is also small. This is the bond length here. If you take carbon is small, but iodine is very big. Iodine is a very big. So this is center to center distance. What will come? Bond length. Bond length is longer. Bond length is shorter. So this is the order. Means what can I write here? Simply bond length order is Ci is greater than, Cbr is greater than, Ccl is greater than Cf. Clear? And now polarity if you take. Polarity depends upon what it is, man. Electronegativity. Polarity means you can simply say charge. Clear? Charge of the ions. Where the charges are more, greater the polarity, greater the electronegativity, greater will be the charge. So fluorine is the most electronegative element than the chlorine, bromine, and iodine. So that's why in this case charges are greater. Clear? And CCl is greater than, Cbr is greater than Ci. Clear? The positive and negative, positive and negative, positive and negative. Clear? Means this bond is highly polar because of highly electronegative atom. Which one is highly electronegative atom? Fluorine. Due to this highly electronegative atom, fluorine is there, and it immediately gains the electron from the carbon and acquires here negative charge. You may ask, sir, here all cases charge is 1 unit only, but you have to see the charge density here. Clear? Charge density, if you see, I already mentioned, taken one simple example. If small the size, higher will be the charge density. Clear? So that's why, and here the positive density will be high compared to remaining one. Least for charge density will be on the iodine. Clear? So this is. Now we know what is the dipole moment. Dipole moment is what is it? 2 into D. If you see D, if I take Ci having the highest D value, but Ci is having the least charge, so that's why multiplication for Ci will come also very least. Lowest value will come. For if you see, for Cr, charge is high, but bond length will be short. Multiplication of these two also you will get a very low value. Got my point? That is, if you multiply like this, and for chlorine, it is charge will also high and bond length also here more. So that's why multiplication of these two, both are satisfied here. Charge is also high, bond is also not that much short, bond is also length, bond is also longer somewhat. So that's why multiplication of the charge and distance will come highest for the CH3Cl. So that's why what is the dipole moment order is dipole moment. You have to remember this order. Clear now? So what is the dipole moment order means? Here CH3Cl is greater than, CH3F is greater than, CH3Br is greater than CH3I. This is the dipole moment order. We will think chlorine is high electronegative atom, greater the electronegativity greater will be the dipole moment we will consider, but not. We have to consider both the bond length and electronegativity. So that product will come highest for the which one here? CH3Cl, not for the CH3. Why not for CH3? So bond length is highest, but charge will be very least. Bond length is highest, but charge is very smallest. So product also will come lowest value. That product will come highest for the CH3Cl. I hope you understand. So this is the what it is here, fourth application. And the next one is calculation of resultant dipole moment. Fifth one is calculation of resultant dipole moment. Resultant dipole moment. So this is also calculation of resultant dipole moment. Clear? So what is the calculation of resultant dipole moment? We will discuss here. If you take calculation of resultant, suppose I will write here there will be a X, and here two atoms are there, Y and Z. Clear? So central atom to surrounding atom. Clear? So now, and the dipole moment for this one is, for this bond dipole moment, just assume these are more electronegative. Dipole moment for this one is mu1 and dipole moment for this one is mu2, and both are inclined with a angle theta. The resultant dipole moment will be what? This is the resultant dipole moment. And what is that? How to calculate that resultant dipole moment? That we have to discuss here. Clear? So we have one formula to calculate the resultant dipole moment. And what is that formula? I will discuss here. Clear? So for these two bonds, this is the dipole moment and this is the dipole moment. That is the resultant dipole moment will be here. So what is the resultant dipole moment is, we have one formula, and here mu1 square plus mu2 square plus 2 into mu1 mu2 and cos theta. This is the square root of. Clear? So this is the formula to calculate the what it is here, resultant dipole moment. Got my point? So if you take in this case, clear? And what is that cos theta and that all I will discuss. And simply I will write here the resultant dipole moment is inversely proportional to theta. Remember this point. Clear ma? So resultant dipole moment is inversely proportional to what it is ma? Theta. What is that one? We will do the examples. Then we will get that clarity. Clear? So what are those? I will discuss one by one. And the next it will come for the organic compounds, how to do the dipole moments. There I will discuss. I will use this terminology. Just remember. Clear? And the next one, fifth one. Clear? So fourth hour, fifth hour, and next one is sixth one. Zero dipole moment. Clear? What it is here? Zero dipole moment. Zero dipole moment. Clear? And I already mentioned for which molecules the dipole moment will be zero. Symmetrical molecules. Our molecules are having regular shape. For regular shape means, and you know, central atom should be present, and around the central atom similar atoms should be present. There is no lone pair on the central atom, and those type of molecules will be called as those molecules will have a regular shape. What will be the regular shape? The central atom and linked to the all similar atoms. Linked to the what it is all similar atoms, and the central atom should not have any lone pair, and those type of molecules will have the regular shape. And for that, dipole moment always will be zero. Clear? So now here dipole moment will is equal to zero for which molecule? Symmetrical molecule R. Symmetrical molecule R. Regular geometry. Molecules are having regular geometry. Regular geometry. For these molecules, dipole moment will be zero. What is that one? I already mentioned CCl4 also. I have already mentioned what is CCl4. What will be the dipole moment for this one? Mu is equal to 0. And if I take here PF5, clear? So PF5, what is this texture means? I will write here. Phosphorus is there, and there will be a fluorine, and there will be a fluorine, and trigonal bipyramidal. This is the shape of this molecule. Clear? You see, central atom. To the central atom, all the surrounding atoms should be what it is same. Is there any central atom having lone pair? No. So this molecule will have the regular geometry. Regular geometry will have that molecules will have the zero dipole moment. If you see this is, you know, phosphorus and fluorine. Fluorine is more electronegative, so dipole moment direction is always towards the more electronegative atom only. So here also more electronegative, and here also dipole moment direction like this. Clear? See now. For these three, first of all, you see for these three. And resultant of any two will be cancelled by the third one, and these two bonds dipole moment resultant will be this one, and this dipole moment, clear? And the bond third one dipole moment are equal and say opposite direction with the same magnitude, so dipole moment will be cancelled here. And if you take dipole moment towards this, and here dipole moment is towards down, up and down, this will be also cancelled each other. So totally dipole moment will be what is one. That is for PF5. If I take here another one is SF6 I will take. That is also having regular geometry. Clear? So what is that? What is the geometry here? CCl4 is tetrahedral. What is the geometry here? Tetrahedral. What is that one? This is trigonal. We will discuss how it will come trigonal. All these trigonal, just bipyramidal. Clear? Some molecules also will have the trigonal bipyramidal, but all atoms are not same. Only two atoms will be same, and there will be some lone pairs here. R bond pair, lone pairs will come. Lone pair it is there. That is not a regular shape. In the same way, if I take SF6, this is octahedral shape. Octahedral shape means sulfur will be here, and there will be a fluorine, and here there will be a fluorine, and this is fluorine. And here up one fluorine and down one fluorine. Same sulfur and fluorine. Fluorine is more electronegative. This is, and for this dipole moment direction for this bond is like this, and for this is. Clear? See now zero or not? Yes. Resultant of this dipole moment will be in this direction. Resultant of, because this is up and this is up. This is up and this is up. Vectors you have already studied in the physics. Resultant will be like this. So that's why for these two bonds resultant will be this. These two are opposite and same magnitude. Zero, upward and downward. So that's why for this one also mu is equal to 1 0. like this. So these are molecules with the symmetry molecules, or we can say regular geometry molecules will have the dipole moment 0. Clear no? And the seventh one, what is the seventh one? It is used to distinguish between the geometrical isomers. What it is not here? Geometrical isomers are distinguished between the cis and trans isomer. Used to distinguish between cis and trans isomers. Cis and what it is not? Trans isomers. You might have studied what is the cis and what is the trans. If you don't study, then I will explain here what is the cis and trans. Clear? So cis and trans means it will, and alkenes. Alkenes mainly show the cis and trans isomers. Clear? If I write here, there is a carbon and a double bond, and the same groups are on the same side, then we will call that one as a cis. See, hydrogen and hydrogen are same side, chlorine and chlorine are same side, and this we will call as a cis molecule. Trans means, and this is the hydrogen and hydrogen. Sorry, here there will be a chlorine, and here there will be a chlorine and hydrogen. Clear? You see, hydrogen and hydrogen both are in which one? Opposite direction. Chlorine and chlorine also are in opposite direction. So that's why this is what it is, trans. This is trans isomer. This is cis isomers. And by using dipole moment, we can easily distinguish whether the compound is a cis or a trans. How means? You see now in this one. And carbon and hydrogen almost electronegativity difference is almost the same. It is 2.1, it is 2.4, almost the same. We need not to consider here direction of dipole moment. If you want, you can do it, but I will not take here. Clear? See now, what is the dipole moment direction for this bond? Carbon and chlorine. Chlorine is more electronegative, and here also what it is now? More electronegative. See, one is like this, another one is like this. What will be the resultant dipole moment? This is the resultant dipole moment. Clear? Next one. If you see, this is what it is not? Dipole moment, and here also dipole moment is what it is not? This is. You see, both are in which direction? Opposite direction. Both are in which direction? Opposite direction. So that's why what will be the dipole moment here? Here dipole moment will be is equal to 0. And for this one, dipole moment is not equal to, resultant dipole moment is not equal to 0, but here resultant dipole moment will be 0 because both are in opposite direction with same magnitude. So that's why dipole moment will be 0. So by using and dipole moment is 0, that molecule we will consider as a trans molecule. If dipole moment is not equal to 0, and that molecule we will consider as a, what it is here, cis. Trans means dipole moment will be 0. Cis means dipole moment will be not equal to 0. This is one concept. And the next one is another 8th one. Distinguish between the ortho, meta, and para isomers. Put the next heading. Distinguish between ortho, meta, and para isomers. O means ortho. O means what it is here? Ortho. Clear? O means. M means meta. P means para. Para isomer. Clear? See now. What is this ortho? You some people may know, some people may not know because we have not started at organic chemistry. So you don't know what is the ortho, meta, and para. Suppose I write here one compound. This is the compound. Clear? So benzene. This is what we will call benzene. Clear? Otherwise you can put here bonds also. That is your wish. No problem. This is chlorine. This is one of the substance I have taken here, chlorine. Clear? Next one I will take. This is chlorine. Adjacent. Both are adjacent. Then we will call these isomers as a ortho isomers. Clear? Ortho dichlorobenzene. Both are in adjacent position. One position and two position. Substances are there in one and two position. Ortho. This is which isomer? Ortho isomer. And second one is meta isomer. Meta means and both are in 1,3 position. Chlorine is one position and another chlorine is third position. That we will call as a meta dichlorobenzene. Clear no? Next one. Para means this is the para. This is the chlorine and this is the chlorine. 1 and 4th position are there, that we will call as a para. Clear no? So for this you have to identify so which one is having highest dipole moment. Clear no? So for this type of molecules means on the benzene same molecules are there, chlorine, chlorine and chlorine. Clear no? So if you see for this one, what happened to the dipole moment? Clear no? Dipole moment is 0, then the molecule is a paramolecule. How and how it will be, we will discuss that. Clear no? Simple. You know that in this case, dipole moment of this bond, carbon, here what it is, carbon and chlorine. The dipole moment direction will be upward. But here what it is, this is a carbon. Benzene means what is carbon, this is chlorine. Dipole moment direction will be downwards. Downwards means what it is, see now, this is upward and this is downward. And the dipole moment are in the opposite direction with same magnitude, because here also chlorine, here also chlorine. Magnitude will be also same. So exactly cancel each other and mu will be 0. Clear? Means they have given ortho, para and meta. So which one is the para? You have to identify among them. So you have to just calculate dipole moment. If dipole moment comes 0, then the molecule is a para. It is only for same substituents, chlorine and chlorine here. If another one is there, it won't be applicable. What my point? This is clear. Now you see. In this case, if you see, the dipole moment is like this and this dipole moment will be like this. Clear? So what will be the resultant here? If you extend this one, clear? This is resultant and this is another one. This is the clear? Means if I write, this is the benzene ring, this is the what is one here? Benzene ring, and now this is the benzene ring. Clear? So now this is the chlorine. I am writing a dipole moment of this in this direction. In this direction. Extend this one. They will combine somewhere. This is. This is. What is the bond angle here? 120 degree. What is the bond angle here? 120 degree. Clear? Simple one example I will say. You see, this is first one. Dipole moment, and it is opposite direction. Here dipole moment is downward and upward. Automatically what is cancel. But you are coming from here to what is here. If you come here, dipole moment is added. You see here, it is 0. Exactly opposite means 0. If it is coming here, it is not 0. If comes here and comes here, what is happening here? Dipole moment is adding. If you are moving from para to meta or ortho, so that's why it will have some dipole moment. Clear? So here in this case, dipole moment will be not equal to 0. Dipole moment will be not equal to 0. And here also you see, and if it is dipole moment direction is in this direction, for this dipole moment is in this direction. So both are in which, what is the angle? If you write here, the angle here is 120, here 60, because here this is dipole moment I am writing, and here one is there, dipole moment, and extend here, you will get it, somewhere it will be. So what is the angle here? Angle is 60. Here angle is how much? 120. But you see, opposite are cancelled. If you are moving close to the chlorine, dipole moment is added. Got my point? So what happened here? Dipole moment is also not equal to 0. But here highest. Here compared to this low, and here 0. Here what is the data? 180 degree. And here what is the data? 120 degree. And here what is the data? 68 degree. Now what I can write here? Ortho is having more and then meta and then para. This is the dipole moment order. Order of what is here? Order of dipole moment. Dipole moment. What is the order one? Order of dipole moment is ortho greater than meta greater than para. Clear? So I have already given one formula. What is the formula? Resultant dipole moment formula? mu1 square plus mu2 square plus 2 mu1 mu2 into what it is, cos theta. This is Clear? We can apply for this one also. You see, because here is chlorine, here is chlorine. How much dipole moment will be here? Here also that much dipole moment only. It's mu1, mu2 are same only. So that's why I will write this one as a mu square, and for this one also, because here also dipole moment of Cl bond. Here also dipole moment of Cl bond. How much dipole moment will be here? And that much dipole moment also present here also. So that's why mu1 square and mu2 square. 2 into mu and cos theta. What is the cos theta one here? 180 degree. This is the cos theta. Clear? So if you do this is cos 90 how much? Minus 1. So here you are getting 2 u square and u square. 2 u square here minus 1. Minus 1 means here also what you are getting? 2 u square. So what will be the resultant dipole moment? 2 u square cancel. Root 0 is equal to what is not? 0 is the dipole moment. But we want you are getting 0 dipole moment. That is. If you take second one is what it is? Second one, 120 degree I will take. Second one, clear now? So mu square plus 2 into mu and mu here also mu square cos 120 degree. This is where theta is 120. Now this is 2 mu square plus 2 mu square into cos 120 minus 1 by 2. Clear? Then what will we get? We see 2 to get cancelled and 2 mu square minus mu square. Then what will we get? 2 mu square means mu square. We will get mu. This is the dipole moment. And this is what it is 120. Clear? Now if you take this is dipole moment for meta. This is for which one? Meta. This is for dipole moment for which one? Para. Now I will consider ortho. Ortho means what it is? Same mu square and 2 mu square cos 60. What is the cos 60? 1 by 2. So what will we get? 2 mu square and here also mu square and here 1 by 2 root over 2 to get cancelled and 2 u square plus u square 3 u square. Clear? So means it is root 3 into u. Root 3 means what? 1.73 into u. So this is what is resultant dipole moment for which one? Ortho. Ortho is 1.732. This is meta is mu. For para is 0. So that's why R is what it is. Ortho is having highest dipole moment than the meta and para. And this is about what it is here and applications of dipole. So next one. Just now I mentioned here dipole moment for ortho, meta and para. I have already given mu is inversely proportional to the theta. Previous I have given or not? See now, theta is how much here? 60. If theta is small, dipole moment will be highest. For here, ortho theta is 60 and here para 120 and here 180. This is having highest degree means angle, lowest dipole moment. See, para is lowest dipole moment and the 60 lowest angle, so that we will have the highest dipole moment. You can apply that. Clear? So just you have to see the bond angle. Clear? So then you can easily write the what is the dipole moment. Clear? So now next case. If you see in this one, clear? So CH3 is a electron donating group that we will discuss in the organic chemistry. Clear? Always it gives the electrons to others. Means here it is a electron donating means here carbon is there. Clear? It is a sp2 carbon. This is sp3 carbon. You can say in that one also. sp2 carbon is more electronegative than the sp3 carbon. What is the electronegativity R here? Electronegativity R is sp is more electronegative than the sp2 than the what it is here sp3. Clear? So here double bonded carbon. This carbon is which carbon? Double bond carbon. Double bond carbon means sp2. It is a all are single bonds are attached to this carbon. So it is a sp3. So sp2 is more electronegative. So that's why dipole moment direction will be towards this. Clear? And here carbon, here nitrogen. Which one is more electronegative? This is. Clear? See now, resultant dipole moment, and this is above, and here also what it is now. This is downward, and this is also downwards. Both will be added. Clear? This is the dipole moment. What is the angle here? Angle is what? It is not 0. Please don't say that here 180. If it is like this, it is a 180 here. Clear? Angle, this is you see parallel, these lines are parallel. This is dipole moment for N here, NO2, and this is also CS3 also dipole moment is in the downward direction. What will be the angle here? 0. What is the theta here? 0 degree. Clear? Now you see in this case. Clear? So dipole moment of CS3 is downwards, and this is like this. Clear? So because like see now. I will write very clearly, you have to follow that. Clear? See now. This is CH3. CH3 is coming what it is downwards, and for this one also what it is here? This is the clear? Resultant, how we will write? We have studied already in the physics. So this is you see, this is the dipole moment of which one here? CH3. This will somewhere it will extend. Clear? So now this is the dipole moment of what it is here? NH2. But because you see head and tail are coincide. A vector it should not be like this. So what I have to do? I have to extend this. I can keep like this. Now what will be the bond angle here? What will be the bond angle? Bond angle is here not 120. Here what is the bond angle? Bond angle is 60. Why? Because we should not consider this is the bond angle. This we should not consider this is the bond angle. You have to write after resultant. This is coming. Clear? Next. Then what will happen now? That is the bond angle. Resultant will be like this. Clear? Next one. If you see in this case, what is the resultant here? You see, this is the resultant, and here another one resultant is this is. Clear? Means dipole moment direction. Now like this, and another one is what it is now. This is what is the angle here? Actually 160 is the angle, but we should not write 60. Why? Because it is not the correct representation. So I will extend. I will put down this. This is. So what is the angle here? 120. Clear? If it is angle is 120, then you see I will write. First one is angle is 0. Here angle is 60, and here angle is 120. So which one is having the highest dipole moment in this case? In this case, the dipole moment highest is 0 because dipole moment is inversely proportional to what is it? For in this case, para is because here both are same, but here both are not same, different only. So para is greater than, meta is greater than ortho. Clear? Understand that you might have studied this one in the physics, how to take the bond angle, because whenever we take, you see, this is actually, we will consider, we should not consider this is a like, angle we should not consider here, because here head and tail are coincide here. So that's why, what we have to write, extend this one, keep this one down. Then what will happen now? This is, if it is there, this is I extended like this. Then what will happen, you see? And previously is 120, means here what it total is 180, it is previous 120, now what it is here? 60 degree, so here 60. Clear? If I write for this, see now, this is the angle. So this is how much angle here? This is 60 degree, but what I will have to do, I will extend this one down. Clear? Means like this. So time will be here now. Here you have to take total 180, here 60 means here what is 120. That is the angle you have to take. Got my point? So this is the what is here? Dipole moment. I hope you understand. So in the same case here also. So this is no problem because the direction of chlorine, carbon and chlorine dipole moment is upward, and this is also upward, and here upward, and this is downward, and here upward, and here downward. Will dipole moment is 0 in this case? Because you may say dipole moment for C and bond direction is upward, and carbon and nitrogen will be downward. Dipole moment will be 0 here? No, dipole moment it is not 0. Why it is not 0? Because both are in opposite direction, but magnitude is not same. Because here chlorine, here nitrogen. So that's why here dipole moment will not be 0, but it will have the lowest dipole moment, least dipole moment. Means here also dipole moment is not equal to 0. But angle you have to see. Here what is the angle? This is upward. This is downward. What will be the angle here? 180. Here what is this sigma? Dipole moment is like this. And this dipole moment is like this. Clear? What is the angle here? 120. Because the angle only we will see here. Here what it is ma? Dipole moment like this and dipole moment like this for this one. What will be the angle here? 60. So which one will have the highest dipole moment? Ortho will have the highest dipole moment than the para than the. This is the dipole moment direction. Clear? So this is having highest dipole moment and compared to this. And in this case, and this is having highest dipole moment compared to this. Para, ortho, and clear? So last one is clear? CH3. So last example, CH3Cl, CH2Cl, CHCl3 and CCl4. Clear? And you already know for CCl4 dipole moment will be 0. CCl4 dipole moment will be 0. Why not? I will write in a simple way, 3-dimensional. I will write like I will take Cl here, Cl and chlorine, and here what is chlorine. Clear? So what is the dipole moment direction? This is, and dipole moment direction this, and this is the dipole moment direction, and this. What will be the resultant of these two? This is. What is the resultant of these two? This is. Dipole moment will be 0. Clear? Now in this case, this is for CHCl. Now CHCl3. I will write there will be a Cl and there will be a Cl and a H, and what it is not Cl. Clear? Now this is dipole moment and this is the dipole moment direction and this is dipole moment direction. Carbon and hydrogen, which one is more electronegative? Slightly carbon is more electronegative. Clear? See now, in this case, these two are in opposite direction. These two are in opposite direction, and due to this and this, dipole moment will be cancelled. Can I say that? But for these two, dipole moment is added. It is not zero dipole moment. If you take and another one, clear now what is that one? Chlorine, and here chlorine and hydrogen and here hydrogen. Clear? If you take in this case, this is dipole moment and here dipole moment, and this is dipole moment towards hydrogen. This is dipole moment towards. This is dipole moment towards what is here. Clear? So you see in this case, the dipole moment in this dipole moment of this is, and a chlorine dipole moment both are in same direction, and here also both are in same direction. Clear? Or if you see the resultant of these two, this is dipole moment and this is dipole moment. If you take dipole moment is this, the resultant will be in this direction. Clear? So resultant not required here. Last one, CHCl3 if I write Cl and H and H and what is not here? H. Clear? So in this case, dipole moment directions are in this. Clear? All will be added. You see, this is dipole moment and this is dipole moment. Clear? So, and if you take the resultant of these two, it will be in this direction, and resultant of these two will be in this direction. All will be added. Clear? Here will be 0. Here some are cancelled. Here adding, and for CH3Cl addition is more. So that's why what will be the order here is this is the order. Clear? If you know CCl4 is 0, then here you can simply see. Clear? So this dipole moment will be in this direction, and these two dipole moments are in this direction. Clear? So this is like this, and another one is like this. Means what will happen now? If you say this is dipole moment in opposite direction. Clear? So like this. If you see for this one CH3Cl, CH2Cl2, CHCl3, CCl4, totally cancelled. Some cancelled, and here added. And for CH3Cl addition, the net dipole moment addition will be more. So this is the order for what it is not here. Understand what here? You see all dipole moments are cancelled here. Here some are cancelled. Added. More will be added here. So that's why CH3Cl will have the highest dipole moment compared to remaining. This is about what it is here. Dipole moment applications very important for complex.